Hello, today we're going to learn how to create a volume in Houdini and generate a result like this. So let's jump into Houdini. Here we have an empty session as usual, and I will start to create a geometry. So press tab and type geo and rope geometry output. Let's go up again. So this was already done, so I will delete and create it again. Okay, so tab and geo, and we will call this setup and dive into this SOP. And to create a volume, we press tab and type volume. And then we can call this density, which is the most common name of a volume if it's just a scalar field. And then press P to edit the parameters. And here I will set the name to .os for operator string. And if you middle click on the name, you can see this will expand to the name of the node, that is density. And we are going to use a scalar volume. You can also use a vector or matrix, but for now we will work with scalar. And that is just a one-dimensional. So every voxel in the volume will contain one value, that is our density. Next, set the default density to 1 so we can see something. And then let's change the size to 2 by 2 by 0.5. And now you can see this is quite coarse, so each voxel is quite big. So let's change the size of the voxels. So if you go to uniform sampling and change this to by size, then we can change the div size to 0.01. And that means that each voxel is basically 1 centimeter by 1 centimeter by 1 centimeter, if we assume 1 unit is 1 meter. Okay, so this volume here consists of small boxes, and each box is a voxel, and each voxel contains a density value. And if the density is 1, you can see it as white, and if it is 0.5, it is weaker, and if it's 0, then we have nothing. So let's see if we can go in and shape this density. So next, type tab and VOP and select Volume VOP and connect this to the density. And if you have never used VOPs before, you can learn more in my VOP lesson. So now let's display this and go inside and delete everything here, and instead press tab and type snippet and press P, and you can see here code snippet, and here we can type VEX code, and you can learn more about VEX in my VEX lesson. So let's first of all grab the position into float variable. So I will type float x equal at p.x and float y equal at p.y, float z equal at p.z. So this grabs the position x, y, and z. And we also want to create a float d for density and set this to 0 initially. And then assign this density to our density. So at density equals d. So this should remove all the values, but we are still getting an error. So let's export the density, and I will just type an asterisk here, and this will export all fields. So now you can see we have 0 density, and let's play around with this. So let's type if x is less than 0, then d equal 1. And let's see what happens. So now we have density everywhere where the x is less than 0. And we can try the y or the z. So now you know how this works. So let's try to make a circle. So x times x plus y times y is less than 1. And if you watch the early lesson about COPs, you have seen this formula before. Okay, so now we have a cylinder because we have 3 dimensionals. If this was 2 dimensionals, this would be a circle. Okay, and next let's use an arctangent here. A tan 2 and x and y. And let's see what we get. And then let's mirror this in x by taking the absolute of the x. Okay, and then let's move this whole formula into a separate variable. So copy this and say float a equal this formula. And then we can instead here check if a is less than 0. And there is something wrong with this. If it's less than 0, let's see if we take bigger than 0. Okay, this should have been a minus here. So let's again change this to less than 0. And now if we take greater than 0, then we get the opposite. Okay, so we want to make this a bit smaller, so we can add here an offset. So let's say +1. And then move everything in the y direction. So I will here subtract, let's see, 0.5 perhaps. And next, let's carve out these edges a little bit. So for this I am going to, let's see, if a is less than like z square and minus, that will give a little bit of roundness, but not enough. So I will actually take the z here and multiply by 2. Now we get it some more roundness to this. And this is what you saw in the introduction. And you can take this and render it out as you saw in the VOP lesson and add glow as was explained there. And then you will get this result. So I hope this was helpful and see you next time. Over and out.